lowers. So when I see that, I see energy not conserved here because the person is coming in and changing that. If the person didn't do that and you attached a block, then it would just kind of like go down fast. But this one is slowly lowering, so energy is probably not conserved here. Now I want to find the actual change in energy, so I have to think about it's gently lowering to rest, so I'm not worried about kinetic at all, that's not changing. But I do have an uncompressed spring, and now I have a stretch spring, so I'm going to gain US, spring energy. That's going to be 1/2 kx squared. K is given, it's 200. X is the displacement. So at first it was 10 centimeters, now it's 15 centimeters. So my X is 5 centimeters. But I don't use centimeters, I use meters to divide by 100, that's 0.05 meters. So however much spring potential energy I have gained is 0.25. So that's how much spring energy I've gained. But I'm also losing height, which means I'm losing gravitational potential energy. So I'm finding the change, right? The mg change in the height. Mass is 1, g is 10, change in the height is the 0.05 meters. I actually lost 0.05 meters, so then this is going to be negative 0.5 joules. So if I'm losing negative 0.5, but I'm gaining 0.25, see how overall you lost? Think about it as if you lost 50 cents and then found a quarter. That's good, but you still lost a quarter, so it still decreases by 0.25. Because that makes sense, because the person would be doing negative work as it lowered it. Here, equal mass, start from rest, forces as a function of time, which is moving fastest. So the one that's moving fastest is the one that has more kinetic energy. The one that has more kinetic energy is the one that has greater change in energy, which means it has a greater work. And work is just the area. So the one that has the greater area is your answer, so A. 2 blocks are released from rest, frictionless, so I'm going to think energy conserved. The 2 block system, does it gain or lose kinetic energy? It was at rest and now it's moving, so it's gaining. Where did this not go? Because it came. So where did this come from? So I said that the whole system's energy would be conserved, so the system gaining kinetic must be loss of system's potential energy, which should make sense because this one's not changing potential, but this one will lose potential. For the system of the 2 blocks in the Earth, is total mechanical energy conserved? Yes, there's no work done because we're including both the kinetic and the potential of everybody. For the system consisting of just the 2 blocks, so only kinetic, is the total mechanical energy conserved? No. This one will be gaining kinetic energy. You can think about it as work being done. So the force that it does work is the force of gravity, because we're not including the Earth. So force of gravity does work, and it is, force of gravity is pointing down, the displacement of this guy is down, so that is doing positive work, which makes sense because we're gaining energy. Net force is a function of distance from 0 to 7, so this guy right here, what is the net change in kinetic energy? So areas, this is 4 times 3, which is 7. And then this one is 4 to 7 is 3. 3 times negative 3 is negative 9 here. That's not right. 3 times 4 is not 7. 3 times 4 is 12 joules. Wow, embarrassing. All right, so I'm gaining 12 joules. This is negative because it's actually below the graph, and I'm losing 9 joules. So then overall, I must have gained 3 joules. So increase in 3 joules. Box of mass M is slowly lifted and brought to rest from height h0 to a height h1. Find the work done. So you can think of it as change in energy. So final energy minus initial energy. Final energy would be the mgh1 minus mgh0. So that's my work done. Now it's lowered. So now still final minus initial, but now my initial is the h1. So So if I do this one minus this one, see how this is going to be negative work done, whereas this one was positive work? Going up, it gained energy. Here, if I do this minus this, that's smaller, so I'll get negative, which makes sense because you were lowered. You were decreasing the energy, or you can think about it as the force is up and the displacement is down. Now, from start to finish, so here back to here, the work done would be the change in energy, which would be mgh0 minus mgh0, which is 0, because you're back where you're starting. So see how I did positive work and I did just as much negative work, so overall you did 0 work. Those cancel each other out.